Welcome back, learners. So now we're going to look at our next concept, being the reaction between magnesium and our oxygen. So to start, we need to know what happens when magnesium reacts with oxygen. So when magnesium reacts with oxygen, it burns vigorously in air. Remember that air, it is a mixture of certain substances, and one of them being oxygen. So now when it burns in the presence of oxygen, it forms magnesium oxide. Now the reactant and the products, they have different properties. We know that the products that are formed from certain certain elements, they have different properties, right? So how do we know that they have different properties? Both the color and the strength of the reactants are going to change. And once you see that the strength, or rather the color of the reactants has changed, that is giving you evidence that a chemical reaction has happened. Now, which chemical reaction are we talking about? That of magnesium and oxygen. So we are going to use a thin strip of magnesium, which is called the magnesium ribbon. Why are we using that? Because the magnesium powder burns extremely quickly, so we will not be able to see the color change. We're not going to be able to see everything that we need to see. So then, when these two things are reacting, when the magnesium and the oxygen are reacting, remember we said they are going to form the magnesium oxide. So in terms of a model to represent that particular reaction, we're going to use our green circle to represent Mg, and our our chemically bonded circles to represent O2. Oxygen is a diatomic molecule and is found in group 16 of the periodic table. Our product being the MgO, which is our magnesium oxide. That is going to be a combination of our our Mg and our oxygen. And we also need to note that this equation is also not balanced. We can see that we have one Mg and we also have one Mg on the right-hand side. One Mg on the reactants, one Mg on the products. So that is balanced. But the oxygen, we have two on the reactants and one on the products. So in order for us to be able to balance that, we need to look at our chemical symbol, whereby we have Mg, which is 1, Mg, 1, O2, 2, and then O, it is 1 on the right-hand side. So let's try to balance this equation. So in order to balance this equation, we are going to check where can we start. We are seeing that O2 is not balanced. So if I put a 2 here on the right-hand side of my equation, remember that coefficient 2, it is going to go for everything in that particular compound, which then means the magnesiums now, they are going to be 2 Mg, and 2 oxygen. But then on my left-hand side, my magnesium is still 1, and then however my oxygen now it's going to be balanced because it is taken care of by that coefficient 2. So if I put in another coefficient 2 there, so that means on the left-hand side I have 2 magnesiums, and then I have 2 oxygen atoms, and then the compound that I'm going to have as my product will have 2 in front, meaning that I'm going to have 2 molecules of magnesium oxide. Now let's see if we can really draw that in a picture. Remember that this one here, it is not balanced. If I want to balance this equation, remember I'm saying that I must have 2 magnesiums on the left-hand side. I need to draw another circle here, and this circle must be green to show that I have 2 atoms of magnesium on the left-hand side. Now remember the oxygen is balanced with the 2, so that is fine, there's not a problem. So we also need to draw another circle here to show that I need to have 2 molecules of magnesium oxide, 1, 2, one being green and then the other one being yellow, to show that now I have 2 molecules of magnesium oxide. Now you notice that now on the left-hand side you have 2 green circles, on the right-hand side again you are going to have 2 green circles. Then on the left-hand side you still have 2 yellow circles, then again on the right-hand side you have 2 yellow circles. Now by doing that, we're showing that our equation is balanced by using pictures. So, to go on to our next concept, which is the general reaction of metals with oxygen. So we're going to be looking at how metals are reacting with oxygens in general, without being specific to looking at the iron and the magnesium, how other metals are reacting with oxygen. So almost all metals reacting with oxygen, they form metal oxide. So that means there are certain metals that when they react with oxygen, they do not form the metal oxide. You may be wondering what those atoms are or what those metals are. So those metals, they are your gold, platinum, and silver. So now when these ones react with oxygen, they do not form the metal oxide. Remember, we can find these elements in our periodic table. The chemical symbol for gold, we know that it's Au. For platinum, it's going to be Pt. And for silver, it is Ag. Remember, the first letter is always capitalized. So to continue, we are then saying that when metals react with oxygen, they are forming metal oxide. So a general equation for that statement would be a metal plus oxygen will form a metal oxide. Remember that the oxygen is always a diatomic molecule if it exists on its own. So in nature, the oxygen is always a diatomic molecule. So looking at an example that we can have here, that magnesium as a group 2 element. So magnesium, it is a group 2 element, and remember the elements in group 2, they are called alkali earth metals. So magnesium as a group 2 element, it is going to react with oxygen. Remember, oxygen, it is a diatomic molecule found in group 7 of our, or group 17 of our periodic table. Now, when these two things are reacting together at room temperature to form magnesium oxide, this is the chemical equation which is going to be formed. Now, remember, you need to make sure that the equations, they are balanced. So, when we are now looking at metals in group 1, we are going to be taking, remember that group 1 atoms, they are called alkali metals, and group 2 metals are called alkali earth metals. So when metals from group 1, which are alkali metals on the periodic table, when they react with oxygen, they will make the formula M2O. So that means the M is going to represent the metal from group 1, and then that 2 will say that is going to mean that we need to have 2 atoms of that particular element from group 1. And that element or that metal will react with the oxygen. Remember, this compound or this product formed here, it is your metal oxide. As we have said, the M will indicate the metal or any metal in the group 1 elements, and then the O, it is going to be your oxygen, and then when they are combining together, their ratio is going to be 2 atoms of the metal to 1 atom of the oxygen. Now, we need to look at this example again, that we said the metal from group 1 is going to react with oxygen. So we have group 1, we can take any metal from that group 1. As an example, we have taken lithium. So lithium reacting with oxygen must form lithium oxide. Remember, the first part is going to be the metal, and then the second part is going to be the oxygen. And then you will have the suffix IDE for oxide. So therefore, Li plus O2 will react to form Li2O. Remember, it's the metal, the M, with the 2, and then the oxygen. This is following that particular general equation there. So, when metals from group 2, so we have looked at metals from group 1. What happens now with metals from group 2? So when they react with oxygen, remember that oxygen is a diatomic molecule, and then these ones are found in group 2. They are called alkali earth metals. So when they react with oxygen, they will have this particular formula of MO, and then they will have the ratio of 1:1. That means for every 1 metal from group 2, it will be 1 oxygen atom. So when they react together, they are going to form our metal oxide, which is different if that oxygen was reacting with the metal from group 1. Because in group 1, remember, we have M2O, but then if the metal is from group 2, it is going to be MO. Remember, this M represents a metal, as it says here. The M indicates the metal from group 2, and then the O indicates the oxygen from group 17 in the periodic table. So therefore, our product is going to be MO when our group 2 element reacts with oxygen. It is still going to be a metal oxide, but the ratio is going to be slightly different from when reacting with group 1 and also reacting with group 2. So now, as we have said, we are going to take any particular element in the group 2 elements, and we've taken calcium. So calcium is that metal found in group 2. It is going to react with oxygen, and remember the product, it is going to follow the MO. So it's going to follow this particular general product which is being formed there, where M represents the metal and O being the oxygen. And as we can see, we have Ca and our oxygen there. And remember again that this equation is still not balanced. We need to make sure that on the left-hand side and the right-hand side, we have equal number of atoms. Now, which elements are we talking about? What are the elements that you find in group 1 and what are the elements that you find in group 2? So in group 1, we find Li and A, K, Rb, Cs, and Fr. So these are the elements that you find in group 1 of the periodic table. You will notice that if you look at your own periodic table, there's an element missing there, which is H. Remember that H, it is not a metal, it is a non-metal. It behaves like a metal because it only has one electron. Now the elements in group 2, these are what we have here. Now remember, when elements in group 1 react with oxygen, they will have the particular general equation of M2O. And when elements in group 2 react with oxygen, their equation are going to be MO, whereby now the M will represent any of these metals that you might use in order to react it with oxygen. And this M2 will represent any of these particular metals here that you might use to react it with oxygen. And both of these compounds that are formed by the reaction between group 1 elements and oxygen and group 2 elements and oxygen, they are both known as metal oxide. The difference will just be in the ratio. So now with that said, I hope you had as much fun with this as I did. I hope to see you next time. Bye.